Let's look at slope for this video. When we are looking at a constant rate of change, that rate of change is called the slope of a line. This slope is specific to looking at straight lines. And in this slide here, we have four different slopes we're going to look at, the four different possible slopes you're going to find with linear graphs. So I'm going to zoom in on each of these, and we're going to kind of analyze the slopes. And in order to look at the slopes, we need to identify 2 points, any 2 points within the graph. And it's helpful to find points that are kind of on the intersections of our grids here. And that way we know that they are at an actual like whole number point. For example, this first one I identified here is at 0, 4. And the second one is at 2, 10. And so those are, at whole numbers, so I can really see what's going on with those points. And we said the slope was a constant rate of change, and so I need to look at the rate of change for this line. And rate of change, as we said in previous videos, is the rise over the run, or the change in the rise over the change in the run. For this first one, that change, we're going up from 4 to 10. That's these numbers here. So it's going up 6. And then our change in x, it's going from 0 over to 2. So our change is 6 over 2, which is actually 3. And you'll notice that that is a positive change, which actually gives us a positive slope. So when we have a line that when we graph it, that line goes up and to the right, whatever angle it goes in, but it goes up and to the right, it will have a positive slope. The number that you're going to get when you get that slope or constant rate of change will be positive. So you may have already guessed what kind of slope this is going to be, but let's go ahead and look at it. We already have our 2 points identified on the graph. So we're going to look at that rate of change that's going on, our change in y over our change in x. Y is going up from -4 to -2. That's going up 2. That's a positive change. And then our x is going from 9 over to 0. That's a negative change. It's getting smaller, going down 9. And so that makes our rate of change, our slope, -2/9. This is a negative slope. So when we have a negative slope, our lines are going to go up and to the left. So these are lines, they can be kind of anywhere on a graph, but they're going up and to the left. Our next line here, once again, we're going to pick any 2 points on our line and identify where those, what our rate of change is. So change in y is how much it's going up on the y-axis, but here it's not changing on the y. So our change is 0. And our x is going from 0 to 2. And 0 divided by any number is 0. So our slope our constant rate of change here is 0, and this is going to be a 0 slope. And our last one, I'm going to pick 2 points, any 2 points, where we can identify what those points are. And once again, we're looking at the change in y over the change in x. We have a change in y this time. We're going from 1 here up to 3. From 1 to 3 is 2. And we're here at 1. That's 4, 8. That's 0.2. So this would be 1. But we're not moving left or right from this point to this point. It's still on the same x value. So the x doesn't change. It stays at 0. Now, we can't actually divide a number by 0. Any number divided by 0 is 0. Any number divided by 0 is undefined. That you can't divide by 0. And so this actually has no slope, because I can't divide by 0, so I'm not going to get a number here when I try to divide by 0. Sometimes you might actually see this written as an undefined slope as well. And there you have it, the 4 possible slopes. When you have 0 slope, all of the lines will be horizontal with the x-axis. And we'll dive deeper into horizontal lines in a later section. Same thing with vertical lines, but the no slope lines, or the undefined lines, will all be parallel to the vertical axis, and we'll look more deeply into those in a future video in a different section. We can calculate slope like we just did with a graph, but we also can calculate it with points. So we can do it with a graph when we are looking for just the changes that's happening. We can do it from a table, which we looked at in other videos, using rate of change, knowing rate of change is slope. But we can also do that with a formula given 2 points. When we have 2 points, if we identify one of the points as point 1, and then we identify the other point as point 2, we can plug them into this formula and solve to get our slope. So I'm going to call my first point point 1, and my second point is going to be point 2. And I just kind of plug in what I've got. My y2 is negative 28, and my y1 is 2. x2 is negative 7, and x1 is negative 1. Now make sure, the biggest error that I've seen in the past is when students kind of get mixed up because there's a negative in the equation, or a subtraction in the equation, and then if there's negative with the numbers. Make sure you're kind of looking at that, not forgetting to put negatives in there if there are. And when you have two minus and negative, you have 2 of them side by side, it becomes a plus. And this gives me that my slope is 5. And as we just looked at before, this 5 is going to be a positive slope. And without actually graphing it, I know that I'm looking for a line that's going to go up and to the right. We'll look at that one more time, with this first one being point 1, second one being point 2, using the formula. And I do want to note, it does not matter which of these is point 1 and which one's point 2. your slope will end up being the same slope no matter what, because it's a constant rate of change. The slope is going to be the same. So I might choose the first one as my 0.1. I might choose the second one as my 0.1. It really doesn't matter because I should still end up with the same answer. And the number 4 will go into both of these evenly when I divide, which would give me -6 over -5. But negative divided by negative is positive, so my answer is actually 6 over 5. And when we're talking about slope, it's good to leave slope as a improper fraction especially if you're going to graph it, because knowing that rate or that change is helpful for graphing. And we will look at that in a little bit. Let's look at a word problem. So we have a biologist. A biologist has been observing a tree's height 10 months into the observation. The tree is 13.7 feet tall. 20 months into the observation, the tree is 16.2 feet tall. What is the rate at which the tree is growing? In other words, we're looking for what is the slope. If you plotted height versus time. And I want to make note, and I think I made note of this in a previous video, that time is the x value when we talk about x and y relationships. And we're given two sets of data. We're given that I want a highlighter. We're given that 10 months is 13 7/10 feet, and we're given that 20 months is 16 2/10 feet. So I can actually take that information given to us and rewrite that as two ordered pairs. You could write it as a table first and then put it as two ordered pairs, but we're going to go straight into the ordered pairs. And once they are ordered pairs, now I can identify which one's going to be 0.1, which one's going to be 0.2. And then use my formula. And find slope. You do want to make sure that y is on the top, x is on the bottom. And one thing I've noticed in the past also is that students want to leave slope like this. We do not leave a decimal in the top or the bottom of a fraction. We do not leave decimals in fractions, so you do want to simplify that. You can change it to a decimal as your final answer. You can change it to a fraction as your final answer. I'm going to actually rewrite it down here so I have a little more space. So if we're going to graph it, having it as 1/4 would be helpful for graphing. But because the data originally started as decimals, I'm going to go ahead and write it as a decimal. And this is feet per month. I don't have enough room to write month, so we're going to put feet per month. So this tree that is being observed is growing about 1/4 foot per month. And that is an introduction to slope.